Okay, I think she will not join the class. Moniba, can you please switch on your camera because it's mandatory to switch on your camera in your class. Okay, Muniba, so I'm starting the class. Hello, Jubita. Good evening.
Good evening, ma'am.
How are you?
Fine, ma'am.
I thought you will not join the class today.
Network issue, ma'am. As I'm in India, it's some network issues there.
Okay, okay, no problem. Yeah, please switch on your camera, Vichit. Okay, see. Okay, so in the previous class, we have discussed basically the reaction with AgCN, right? And the reaction with KCN, right? So just remember in both that when you are using the KCN, so basically KCN is your ionic type, right? So in that, the C and the nitrogen, it will be the attack will be from the carbon side, right? And the formation of cyanide will be there, right? The propane cyanide will be there, but in the when the attack from the when you react, the reaction is with the AgCN, right? Silver cyanide. So with the basically the silver cyanide का जो character होता है, there is a covalent character, right? तो वो आयन में dissociate नहीं हो पाता है. So due to that, the carbon side से attack नहीं होके nitrogen side से attack होता है on the this alkyl group, and it will form the isocyanate, right? So just remember when you are using KCl, cyanide के साथ अगर potassium आप use कर रहे हो, sodium use करते हो, right? So in that case, there will be a formation of cyanide. But when you are using AgCl, right, silver cyanide, so यहाँ पे क्या होगा? The attack from the nitrogen side, and here the isocyanide formation will be there. You will see the isocyanide, alkyl isocyanide will be the product. Okay, so just remember the difference between these two. Similarly, when the reaction of alkyl halide with AgNO2 and KNO2, let's see what will be the product. So basically, write down the first case, case number 1. So it's a reaction with, we will discuss first with the KNO2, potassium, right? Reaction with KNO2, right? Now see, again the KNO2 is ionic in nature, right? KNO2 is ionic in nature and it will dissociate. It will dissociate, write down. KNO2 is ionic in nature. So it's ionic, so it will dissociate and dissociates into K plus and NO2 minus. Right? NO2 minus. Basically, NO2 को हम कैसे दिखाते हैं? N, right? And here there is a double bond between this oxygen and here oxygen, यहाँ पे negative charge. Right? So from here, this oxygen side से attack होता है alkyl group पे. Right? Let's see the reaction. First, write down KNO2 is ionic in nature and it will dissociate to form K plus and NO2 minus, in which NO2 minus has negative charge, right? Has negative charge on oxygen atom. So therefore, alkyl halide, right, is attacked, this is attacked by oxygen atom, forming alkyl nitrite, right? So basically in this, when the KNO2, see the reaction, KNO2 first will be, it will, because it is a ionic in nature, so it will dissociate to form K plus NO2 minus. And you know there is a lone pair. Now, what happens? What happens here? K plus and NO2 minus. Now, this NO2 minus, oxygen pair, this is a double bonded, and there is a negative charge over here. And when the alkyl halide came, when the substrate came, so this oxygen page of minus charges, so it will attack on this the carbon of the alkyl group, and it will form RONO plus KX. Okay, so that's the reaction. Basically, basically what happens when you react the KNO2 with RX, with alkyl halide, what happens? The attack from the oxygen side, because we know that it is again an ambidentate nucleophile. NO2 again is an ambidentate nucleophile, means there is a donor side कितना होगा? 2, more than one there is a donor side, so it can attack from this oxygen also, or either it can attack from this nitrogen also. But when it is attached to the, similarly the case of the cyanide also, KCN, तो कहाँ से attack होगा? Oxygen, the carbon side से, right? And in KNO2 the attack will be from the oxygen side, not from the nitrogen side. Yeah. Now second one, right, on the second case, case number 2, reaction with, this is very important, AgCN and KCN, and AgNO2 and KCN. These two reactions, these four reactions are very, very important. Okay, so this is from the previous year question also. In previous year question, I have seen this type of question. So what will be the product when you just treat it with the alkyl halide? When NO2 reacts with the alkyl halide, what will be the product? Write on the mechanism of the reaction. Right, so this type of question can come. So second case is reaction with AgNO. Okay, now see what happens here. So basically when NO2, what happens? Because we know that this is an ambidentate nucleophile, but in this case, what happens? This is basically AgNO2, as I told you, is a covalent in character. It is a covalent nature. It has covalent nature. So the oxygen atom doesn't bear negative charge here, right? Because it is not ionic. And nitrogen is less electronegative than oxygen. We know that. Nitrogen is less electronegative than oxygen. So what happens here? So the attack is from the nitrogen side, not from the oxygen one. Right? So what will be the reaction here? So this is, suppose this is your AgONO. Right? So this is your AgNO2, the structure of AgNO2, right? what happens when the alkyl halide came, the attack from the nitrogen side. The nitrogen, it will attack the carbon of alkyl group. And what will be the reaction? What will be the product here? So the R, it will combine with nitrogen, right? So here will be positive charge plus AgX. Okay, so that's the reaction when the alkyl halide reacts with AgNO2. Write down as AgNO2 is covalent, the oxygen atom does not bear negative charge, and nitrogen is less electronegative than oxygen. Yeah. So therefore, nitrogen attack on alkyl halide. Alkyl halide means the carbon of the alkyl halide forming nitroalkene. Nitroalkene. Yeah. So just remember that. Yeah, if you want to write down the definition of amide nucleophile, because sometimes in 1 mark question also, they just ask you define what is amide nucleophile. Give examples. Okay, so write down amide nucleophile definition. Ambidentate, ambidentate nucleophile. So basically, what is ambidentate nucleophile? That type of nucleophile which have more than one donor site, which have one more than one donor site, or you can say which has more than one nucleophilic center for attacking and bond formation. Yeah. So the nucleophile which have more than one donor sites or nucleophilic center for attacking and bond formation. Example, write down. Example, you know very well, it's cyanide ion, Cn minus ion, right? NO2 ion, AgNO2, right? Etc. Yeah. Here's a very interesting question. I will discuss it by using a question. Write down the question when three methyl butane 2-ol is treated with HBr, with HBr, the following reaction takes place. Reaction takes place. First reaction, CH3, HBr, and product is also given. Product is also given. Where is attached over here? CH3, CH3, CH3. Yeah. So this is your reaction. When 3-methyl-butane 2-ol, yeah, so this is your 3,1,2,3-methyl-butane, which when it is treated with HBr. So this is the product. This is your product. Now the question here is, give a mechanism. You have to write down the mechanism. आपको पूरा mechanism show करना होगा. How this reaction occurs. Step by step, you have to show the mechanism. So give a mechanism for this reaction. For this reaction. And here's a hint. Here's a hint given in the question. The secondary carbocation, which is formed in step 2, step 2, rearranges to a more stable, tertiary carbocation, tertiary carbocation by a hydride shift, by a hydride ion shift from third carbon. ये तो आपका क्वेश्चन ईज कर दिया ये हिंट देके, राइट? थर्ड carbon atom, that's the hint given. Okay, now first try to understand the question. When 3-methyl butane 2-ol is treated with HBr, okay, so the following reaction takes place. This is a reaction given, right? So reaction is given and the product is also given. And what you are supposed to write, so you have to give a proper mechanism of this reaction, how this reaction proceed and how this product came, right? And the hint is given that in the second step number 2, the secondary carbocation formation will be there. And that secondary carbocation formation will be little bit unstable, so it will rearrange itself to a more stable carbocation, which is tertiary carbocation, right? By a hydride shift. वहाँ पे एक hydride shift होगा. Hydrogen will be shift there. Okay, let's see. It will be very easy when you see all this step. So what you are supposed to do, this is a first, this is your reactant, right? So when 3-methyl butane 2-ol. Okay. So this is your, on the third position there is a methyl, right? And here there is a OH group, right? This is the 1, 2, 3, 4, 4 carbon chain. So I have written this 1, 2, 3, 4, right? This is your 3-methyl butane 2-ol. Now what we are supposed to do? It has been treated with HBr. Now we know that HBr is a ionic type, right? So H plus and Br minus. It will dissociate to form H plus and Br minus, right? And we know that this H plus, right? So basically what we are supposed to, यहाँ पे क्या होगा? So this oxygen, this OH group, basically this OH group, this abstract this hydrogen. ये OH group क्या करेगा? ये hydrogen को abstract कर लेगा. It will abstract that hydrogen because it has a you can see the lone pair. Oxygen has a lone pair, right? So it will attract this H plus, right? It will attract this H plus ion, and so it will form. So basically when it basically यहाँ पे अगर ये हाइड्रोजन को एब्स्ट्रैक्ट कर लिया तो ऑब्वियसली यहाँ पे क्या आएगा? OH2 plus, right? Basically this OH2 plus, this is your very unstable type of very unstable होता है. यहाँ से क्या होता है? This will, यहाँ से water will be removed. You can see OH2, this is your water. So यहाँ से dehydration हो जाता है. Water will be removed, right? And now see, when the water will be removed from here, so this is the, here the carbocation will be formed. यहाँ से water remove हो गया, यहाँ पे carbon पे क्या आ गया? Positive charge. There will be a positive charge. ये step clear है? Is it clear to you all? Right? It's very easy. What you are supposed to do in the first step is the HBr, H plus and Br minus. Right? So this OH will abstract this hydrogen. ये abstract कर लेगा hydrogen को, तो यहाँ पे कितने hydrogens आ गए? 2 hydrogens, H2O. Now this is very unstable, तो यहाँ से क्या होगा? Dehydration हो गया. Dehydration means water will be removed out. Right? So water will be removed out. So यहाँ पे carbon पे क्या आएगा? Charge, positive charge. right? So now the carbon has a positive charge, right? Now what you are supposed to do, see, you can see this is a which type of, you can see in the hint section, the secondary carbocation is formed in the second step, right? Second step में क्या हुआ? Secondary carbocation is formed, but the secondary carbocation is not very much stable. So what it will supposed to do? You can see over here. This is यहाँ पे क्या है? This is one hydrogen is also there, right? One hydrogen is also there. If it is carbon, if it is carbon here, so one bond, third bond, and the fourth bond with hydrogen. यहाँ पे CH है, so we can show the hydrogen just like this, right? So now what we are supposed to in the second step, because this secondary carbocation formation हो रहा है, तो secondary carbocation is not very much stable. So what will happen here? This hydride यहाँ पे rearrangement show करेगा. This positive carbocation will show some rearrangement. तो यहाँ से क्या होगा? Hydride shift. This hydrogen will shift here, right? यहाँ पे क्या होगा? Hydride shift होगा. Now see. So basically, this is your rearrangement. It will show some rearrangement reaction. So rearrangement is basically for the stability, right? The that compound, it wants to be more stable. So what it supposed to do? It just rearrange. Rearrange कैसे करेगा? So basically यहाँ पे ये hydrogen की shift होगी. This hydrogen ion shift from here to here, right? So when the hydrogen इससे shift हो रहा है तो कैसे बनेगा हमारा यहाँ पे? It will form some CH3 will be there और यहाँ पे positive charge आ जाएगा. Now see, is it clear now? And yeah, you can just यहाँ पे आप hydrogen show कर सकते हो. That hydrogen यहाँ पे shift हो, यहाँ से यहाँ shift हो गया hydrogen, right? So basically hydrogen shift will be there, right? So basically hydrogen वहाँ पे step 2 में क्या हुआ? Secondary carbocation, it rearranges to itself, right? And it just forms a, it will convert into the tertiary carbocation. And we know that tertiary carbocation is more stable, most stable, right? So tertiary carbocation बन गए. Yeah. Now what happens in the next step? We know that यहाँ पे तो H plus का ही हुआ था use, but Br is also there in the reaction. Br minus is also there in the reaction. This is a nucleophilic type, right? So bromine is a nucleophile over here, right? So what we are supposed to do, this nucleophile bromine, it just attack, yeah, it will just attack here, right? Because carbocation is a positive charge and Br is negative charge, so it will attack to that carbo, the center, and यहाँ पे ये आपको formation हुआ bromine. Now see, the product is same or not? Yeah, it is same. 1, 2, 3, 4, 4 carbon, right? And 1, 2, 3, 4. And on the second carbon, there is a methyl group and bromine attached, right? So you can see this type of, you can show by using this type of mechanism. First step, what they are supposed to do, because यहाँ पे क्या होगा? Hydrogen abstract करेगा ये OH group. Now here the OH2 minus, OH2 plus will be there. Then dehydration हुआ in the second step. Third step will be the rearrangement of the hydrogen and your carbocation. Yeah, hydride shift basically हुआ, and it just convert into the more stable carbocation, which is tertiary one. Now, if tertiary carbocation में वो convert हो गया, then the bromine minus will attack to that carbocation, that carbon center, and it will form that product. Final product will be this. Yeah, is it clear now? Jivita, are you there,
Yes,
बच्चे? Yeah, is it clear?
yes, ma'am.
And yeah, just see here. In the second step, because second step is very much important. So what happens here? CH3, there's a hydrogen over here. Yeah, and there's a positive charge. So what happens, because this is a secondary carbocation, so this hydrogen basically shift here, right? So basically this step is known as, this shift is known as 1, 2, because suppose this is first position and this is second position, first and second position. So basically 1, 2 hydride shift. This step is known as 1, 2 hydride shift. Hydride is shifting from one position to the second position, right? 1, 2 hydride shift is second. Yeah. Now this hydrogen, suppose this is first position, so यहाँ second position पे hydrogen shift हो गया. Now carbocation is. This is one was secondary, and this is tertiary, which is more stable. So which is more stable. Okay. Okay, let's do some more questions. Yes, Maniba.
But we're naming it the other way around, right?
Naming of this product.
Yeah, we're giving the numbering from the other side, right?
Yeah.
So then the hydride shift won't be from the other side.
Hydride shift from won't be other side means this is your, suppose this is the first position, right? First and second. ये
Yeah, but
हम
we're numbering it from
not
the.
not the whole molecule का numbering करते. That we do in the nomenclature. Right? We are not supposed to write down the name here. Right? So if we are talking about the two carbon position only, carbon जहाँ से hydride shift हो रहा है, जहाँ पे shift हो रहा है, right? So we are talking about that two, only two carbon position, right? So when the hydride shifts, so we are talking about only two carbon position, this carbon position and this carbon position, where the carbocation is there. Carbocation center and this hydrogen to which the hydrogen is attached. These two carbons. Suppose this is one carbon and this is two carbon. Right? So hydrogen shift from one to second position. Right? So that's why it is known as 1, 2 hydration. Yeah. हमें पूरे मॉलिक्यूल में पूरे इसमें नेमिंग की जरूरत नहीं है. वो हम तब करते हैं जब हमें नेम लिखना हो. नॉमेनक्लेचर में करते. Right? Okay, so let's do two more questions, then we'll be more clear. You will do that question. Write down PH3, and here the bromine group is attached. Now, and if I give you water, right, and in the presence of NaOH, this reaction occurs in the presence of sodium hydroxide. Okay, in the presence of water. Now, what we are supposed to do, we know that, see, we know that this bromine, what will happen? The bromine will be removed from this, right? यहाँ से bromine निकल जाएगा. What will happen? It will form a carbocation. Again, here's our hydrogen को आप ऐसे show कर सकते हो, because you know there is a CH group over here, right? Now, here the bromine will be removed, so यहाँ पे क्या आ जाएगा? Positive charge. Carbocation will be formed. Again, the secondary carbocation, right? Now, again the hydrogen shift. This hydrogen 1,2 hydride shift will be there. This hydrogen is shifts here, right? Now this hydrogen if shift here, so it will have a positive charge, and here the hydrogen will be there, and this. Now this, see NaOH, sodium hydroxide. So what is the nucleophile here? What is the nucleophile here? You have to check it out. Na plus and OH minus, right? So OH minus negative part is the nucleophile. So now in the next step, this OH minus, this is OH minus, so obviously it will attack on the carbocation center. And this is a tertiary carbocation, so it is very most reactive. Right? तो यहाँ पे reaction काफी fast होगी, the rate of reaction will be very fast, and you will get the product. And what will be the product? CH3 group, right? And you see, it's very simple. अगर आपको mechanism नहीं लिखना, only you have to write down the product. So it's very simple. जहाँ पे CH3 group है, right? So उसी के वहीं पे आपको nucleophile just attach the nucleophile here, you will get the product. That's very simple. Third one, next question. CH3, and here I have written I. Now again, मैंने water दे दिया and KCl. Now write down the product and tell me what will be the product. Instead of hydrogen, there is a methyl group over here. So this is your methyl shift, not the hydride shift. Yeah, it's very simple. This is a methyl shift. Similar reaction, similar mechanism आप follow करोगे जैसे कर रहे थे, same to same. Right, so what will happen here? Again, the iodine will be removed from here and carbocation formation. Secondary carbocation formation will be there. CH3 and here the CH3 group. Now you can see this hydride shift. No, not the hydride shift. This is a methyl shift. So this methyl shift over here, right? And this step is known as methyl CH3 shift means methyl shift. So the methyl shift here and here the carbocation will be formed, which is more stable, tertiary carbocation. Now KCN. So obviously this is a ionic type of molecule. So K plus and Cn minus. So cyanide Cn minus is your nucleophile. And I just told you every time when it is KCN, always किस side से attack होगा? Carbon side, right? Always carbon side से. Okay, so it will be when Cn minus attacks, Cn attack to this carbon center, and what will be the product? Here the CH3. Here the cyanide, Cn, and here the CH3 as it is. Okay, so that's the product. That's the product. Is it clear? Okay. One more example, right now. Suppose there's a cyclic type of compound. The reagent is water and KOH. How to proceed this type of question? See here, what will happen? The bromine will be removed from here. Bromine यहाँ से निकल जाएगा and here the carbocation. Here the CH2 group is there, right? So CH2 group and here the positive charge. This is a carbocation, right? Carbocation. So what happened here? What happened here? So this in this case, when the cyclic structure is there, cyclic type of molecule अगर होगा, तो what happened? यहाँ पे क्या होता है? यहाँ पे ring extension हो जाता है. What happens? Because you can see there are four membered ring. One, right? One, two, three, four. Right? Four carbon का cyclic ring है. What happens there? यहाँ पे ring extension होके this carbon it is also included in this cyclic structure. Right? So ring extension होता है. Now see suppose if this is your first, if this is your first, second, third, fourth, fifth. Okay. So what happens? ये जो होता है carbon, this bond ये extend होके इससे attach हो जाता है. And so basically this is known as your ring expansion. Ring expansion. What will happen? The four-membered ring it just convert to the five-membered ring. Five-membered ring, right? And suppose यहाँ पे ये first position था तो यहाँ पे आपका carbocation का formation हो जाएगा. Five-membered ring. Carbocation formation here. Now what we are supposed to do जब carbocation का इस carbon पे carbocation था ये right this carbon first carbon तो first आपने यहाँ से start की first second third and so on. So basically ring expansion happen and you just get the five membered cyclic ring, right? And the carbocation is there this carbon. So now similar thing you will do KOH potassium hydroxide so K plus and OH minus. So OH minus is your nucleophile here. So this nucleophile, it will attack to this carbocation center, carbon center, and just attach this hydroxyl group to that position. So that is your product. Very simple. Yeah. So when there is a cyclic type of a structure, cyclic अगर ring होगा, तो what you are supposed to do, just ring expansion करा दो. अगर four membered ring है, तो just five membered ring, right? So it's very easy. And after that, after the ring expansion, just attack the nucleophile. उसके बाद आपको nucleophile का attack कराना. Is it clear? Okay, so the next, write on the next heading. मुझे और भी questions discuss करने थे, but I will give you in the homework. But you guys don't submit your homework. Why? Can I know the reason? Muniba and Jibita, I always give you the homework after the class, but I have not, you have not submitted yet. Why? 2 to 3 questions, 3 to 4 questions only. कितना time लगता है करने में? Not more than 10 to 15 minutes, I think. Please do that question, बच्चे. Please, Muniba. Yeah. वो आपका रिवीजन हो जाएगा जब मैं क्वेश्चन देती हूँ तो आफ्टर द क्लास देती हूँ उसी टॉपिक को मैं कवर करती हूँ जो आज मैंने पढ़ाया होता है इफ यू डू द क्वेश्चन आपको डाउट्स भी होंगे क्यों ऐसा हुआ रिएक्शन में व्हाई दिस मैकेनिज्म तो यू विल आस्क द क्वेश्चन आल्सो या तो एलिमिनेशन राइट ऑन द नेक्स्ट हेडिंग एलिमिनेशन रिएक्शन या So the see, till now we have studied about the new substitution reaction. Substitution reaction में हम क्या करते थे? We just replace one group with the another one. But this elimination reaction is very different from the substitution reaction. Eliminate, we are supposed to eliminate some group. Okay, and instead of आप eliminate कर रहे हो तो किसी और को आप replace नहीं कर रहे हो किसी और को नहीं ला रहे हो substitute नहीं कर रहे हो you have to only you are supposed to eliminate okay push out from the reaction right so elimination reaction write down the definition first the reaction in which atoms or group of atoms of of substrate are removed and not replaced right they are just removed from adjacent carbon from adjacent carbons in presence of a base in presence of a base to form and what we are supposed to form product kya hoga basically the product is unsaturated compound yeah unsaturated whenever we use the unsaturated word it means that where it could be your double bonded or triple bonded alkene or alkyne group right so unsaturation wahan pe aa jayega either double bond or triple bond so compound is called elimination reaction eliminate कर रहे हो आप just elimination yeah suppose there's a see this group suppose yeah इस कार्बन पे आपका any x atom is there and any y atom is attached to this carbon right and this is your elimination reaction so basically what is elimination reaction you are supposed to eliminate you are supposed to remove some group of atoms or only one atom right so here and what will be the product so basically elimination reaction में product क्या बनता है unsaturated compound बनता है right you can unsaturated के लिए आप double or triple bond use कर so unsaturated compound so just remove this xy okay if you are removing this y group y atom from this carbon तो आपको next carbon से इसको eliminate करना है means you are eliminating xy xy को आप eliminate कर रहे हो right so what will be the products obviously when you are removing this xy so obviously the product will be unsaturated right? So to satisfy the valency of carbon so I have written carbon carbon double bond of air right so this is your product now see examples of some elimination reaction examples of elimination reaction or you can say the type of elimination also. So examples could be sometimes what happens, only water is removed from the compound, given compound. अगर आप water भी remove करते हो, that is again a elimination reaction, right? Elimination means dehydration. Dehydration again is a type of elimination reaction or example of elimination reaction. Similarly, hydrohalogenation. Dehydrohalogenation means D means removal, hydro means H hydrogen group, and halogen means hydrogen and halogen group को आप remove कर रहे हो, HX को आप remove कर रहे हो. So that is again a type of or example of elimination reaction. Okay, so write down the examples. First one, dehydro. The word suggests that D means removal, hydro means hydrogen, and halogen means halogen group. Halogenation. Yeah, means the removal of HX. So HX को आप remove करते हो. HX is removed. Yeah. And yeah, in this type, if you are removing the X from one carbon atom, so आपको H को आपको next उसके adjacent carbon से आपको H को remove करना है. Right? So just remember that if you are removing the halogen group from the one carbon, then you are supposed to remove the hydrogen from the adjacent carbon. From the adjacent carbon, we will do some examples also. But first, let's know what are these terms. Dehydrogenation, dehydrohalogenation. The next term is dehydration. Dehalogenation. First one was dehydrohalogenation means HX will be removed. Second one is your dehalogenation. Halogenation. D means removal and halogenation means halogen group. Right. So removal of, just a second, removal of halogen group X2. Yeah. So what happens in dehalogenation? Basically X2 is removed. X2 is removed and X2 could be your F2, Cl2, Br2, I2, anything. Third one is your dehydration. Dehydration. Dehydration means hydration किसके लिए हम use करते हैं? Water के लिए. Water is removed. H2O is removed. Yeah, one more thing right on the note. Generally, heat is required. Basically, आप external energy की requirement होती है for the elimination reaction. Means the heat requirement will be there in the elimination reaction. Okay, write down in notes. Generally, heat is required. Heat is required during elimination reaction. Yeah. Okay, now we will discuss one by one each and every example. First one, write on the heading dehydrohalogenation. Dehydrohalogenation. What is dehydrohalogenation? Basically, हमें HX को remove करना है. HX is removed. Just remember that. So write down, when alkyl halide reacts with alcoholic KOH, alcoholic KOH, potassium hydroxide, then it undergoes elimination reaction. Elimination reaction. Elimination means dehydrogenation here. Dehydrohalogenation here. Elimination reaction and forms corresponding unsaturated compound. So here alkene will be formed. Corresponding alkene. Yeah, so just remember when you remove the HX, so alkene का formation होता है. Similarly, write on the reaction. Suppose here is a X, right? और यहाँ पे आपका hydrogen, right? Suppose यहाँ पे आपका this is your suppose ethane molecule is there and you have just removed one hydrogen. So basically, this is your ethyl halide, right? Ethyl halide, right? So what we are supposed to do in the presence of alcoholic KOH and in the presence of heat, because heat requirement is there in the elimination reaction. So what we are supposed to do, आपको simply HX remove करना है, right? So if you are removing the X from this carbon, alpha carbon, suppose the halogen group, see what is alpha carbon and what is beta carbon. Just understand this concept. The halogen group which is attached to the carbon. The means the carbon to which the halogen group is attached. This carbon is known as alpha carbon. और उसके adjacent carbon जो होता है, this is known as your beta carbon. And this beta carbon के जो adjacent होता है, this is your gamma, then delta and so on. So basically starting कहाँ से होती है numbering? So the carbon to which the halogen group is attached. Right, so the carbon to which the halogen group is attached is alpha carbon, and this is your adjacent वाला क्या होता है, beta carbon. So what we are supposed to do in the dehydrohalogenation reaction, because हमें HX remove कराना है, right? So HX हम जो halogen group लेते हैं वो alpha carbon से लेते हैं and the hydrogen from the beta carbon, right? So the halogen group from the alpha carbon हम remove कराते हैं and the beta carbon से हम H लेते हैं, right? Means the adjacent carbon of the alpha carbon, adjacent carbon of alpha carbon. तो क्या हो जाएगा आपका? Obviously इसे आप remove करा दोगे X और H को, H and X when it is removed from this molecule. तो what we are supposed to do? तो आपका यहाँ पे alkene का corresponding alkene formation है. या सो सी, ये दोनों बॉन्ड, ये दोनों एच एक्स निकल गया, राइट? एंड यहाँ पे डबल बॉन्ड आ गया टू सेटिस्फाई द वैलेंसी ऑफ द कार्बन. इज इट करेक्ट? ओके, अंडरस्टैंड अनिबा? या, वेरी सिंपल. ओके, सो लेट्स डू सम क्वेश्चन, एग्जांपल्स देखते हैं. सो सपोज मैंने आपको दिया CH3 CH2 एंड Br in the presence of alcoholic KOH. Now what will be the product? Tell me. Very easy. See, the halogen is attached to this carbon, so this is your alpha and this is your beta carbon, right? So what you are supposed to do, यहाँ से आप एक हाइड्रोजन लेस कर दोगे, यहाँ से एक हाइड्रोजन रिमूव करोगे और यहाँ से आप ब्रोमीन रिमूव करोगे. तो यहाँ पे जब हाइड्रोजन आपने एक रिमूव किया तो इट विल हैव CH2 ग्रुप, राइट? एंड यहाँ पे टू सेटिस्फाई द वैलेंसी इथीन विल बी फाउंड, राइट? इथीन का फॉर्मेशन होगा. This is the first example. Write on the second one. Okay, so if it is, now tell me. Same. Alcoholic KOH and in the presence of heat. See, if it is now, you can check it. This is your alpha carbon, but there are two beta position. There are two beta carbon. अब हम कहाँ से remove करें hydrogen को? But if it is a symmetrical type of molecule, तो आप कहीं से भी remove करा सकते हो. The answer will be same. If it is a symmetrical type of molecule, so you can, it's up to you to suppose this is beta 1 position and this is beta 2. तो आप कहीं से भी remove करा सकते हो. The answer will be same. If you remove the hydrogen from here, तो यहाँ पे आएगा double bond, right? If you are supposed to, यहाँ से अगर आप beta 2 से आप remove कराओगे hydrogen और यहाँ से bromine group, तो यहाँ पे double bond आएगा. और यहाँ से अगर आप remove कराते हो B1 से beta 1 position से, तो यहाँ पे आएगा, right? सब similarly you can see over here, यहाँ पे आया, right? और यहाँ पे आया. When you try to name this type of compound, तो answer same होगा. So it means that अगर आपका symmetrical type of molecule है, right? तो you can remove the hydrogen from any beta carbon. But if it is unsymmetrical, so there is a rule you have to follow, right? अगर वहाँ पे आपका unsymmetrical type है, तो that is a problem. I will explain it to you. उस टाइप के क्वेश्चंस को कैसे प्रोसीड करना है. Yeah, see, Example, see the example. Okay, first write down. First मैं आपको rule लिखा देती हूँ. When, write down in note, it's important. Important notes. When there are more than one beta carbons, one beta carbons, then multiple products are formed. Multiple products are formed. Are formed. Now, how we decide which one is the major one and which one is the minor one? अगर आपका multiple product formation हो रहा है, तो how we can decide which one is the major product and which one is the minor product? So there's a rule which is known as Fedzeff rule, right? So just write down the major rule, the major product is determined by Fedzeff rule, right? And what does Sedgwick rule says? So Sedgwick rule ये कहता है कि hydrogen is removed from that beta carbon which bears less number of hydrogen. जहाँ पे less number of hydrogen होगा, that beta carbon, वहां से आपका hydrogen remove होगा. That's the Sedgwick rule, right? So just write down. It's very important rule. It states that it states that the Sedgwick rule states that the hydrogen is removed from that beta carbon which bears lesser number of hydrogen. That's very important. Yeah. So in elimination reaction, more substituted, more substituted alkene is the major product. जहाँ पे substitution ज़्यादा होगा, that is the major product. That is the major product. Okay, let's see the example. Example. So if I take this molecule, here's the bromine group, right? And again the same alcoholic KOH में ले रही हूँ in the presence of heat. So now you can see the bromine is attached to this carbon. So this is your alpha carbon, right? And you can see there is a beta. Suppose this is your two beta carbons are there, right? Suppose this is your alpha carbon. Alpha carbon कौन सा होता है जहाँ पे halogen group attached होता है this carbon के. So this is your alpha carbon. And so suppose this is your beta 1. You can see there are two beta carbon. So beta carbon कौन सा होता है which is adjacent to the alpha carbon. तो adjacent कौन कौन से है? इस side भी है and इस side भी है. तो suppose this is your beta 1, right? And this is your beta 2. There are two beta carbons. Now Sedgwick rule क्या कहता है? Sedgwick rule said that हाइड्रोजन कहाँ से रिमूव होगा? बिकॉज ब्रोमीन तो यहीं से रिमूव होगा अल्फा कार्बन से. So from where the hydrogen will be removed because there are two beta carbon position, right? So beta carbon, Sedgwick rule क्या कहता है? Hydrogen is removed from that beta carbon which bears lesser number of hydrogen. Lesser number of hydrogen, right? So lesser number of hydrogen you can see यहाँ पे 3 hydrogens है. It's CH3, right? Because यहाँ पे terminal पे and यहाँ पे क्या है? Hydrogen is 2 hydrogen. So obviously यहाँ से आप remove करोगे. राइट तो अगर यहाँ से आप रिमूव करोगे. हेलो. यस मुनीबा व्हाट हैपेंड बच्चे. हेलो.
Can you hear me?
Yeah, Maniba. Yeah. So see what I said you, set rule. Just remember this rule. This is very important. Set rule. Suppose we have two beta carbon position, right? So we know that we have to remove the halogen group from the alpha position, right? So we just remove the halogen group from the alpha position. But हम beta position से which beta position को हम prefer करेंगे, right? So basically जब whenever the beta carbon is more, so what we are supposed to do, we have two products, more than one products, right? And this one is your major product. The major product is according to the Setzer rule, right? So Setzer rule states that the hydrogen is removed from that beta carbon which bears the less number of hydrogen, right? Now you can check it. There are beta one position, right? This is B1 position and this is beta two. And this beta 2 has only two hydrogens there. Two hydrogen is there, right? And there are three hydrogens, right? Obviously यहाँ से हम remove करेंगे hydrogen को, right? So whenever you remove the hydrogen from here and the bromine from here, तो obviously यहाँ पे unsaturation आएगा, यहाँ पे double bond आएगा. So that will be your major product. The product will be more than one.